Good morning, students. Last time we have started hydrocarbons, in which we have completed alkanes. After completion of alkanes, we have started alkenes, in which we have seen introduction, then isomerism in alkenes, and after that we have seen methods of preparation of alkenes. Now next point we are going to see is physical properties of alkenes. Now look here. First physical property is polarity. Now these alkenes are non-polar compounds, or they are weakly polar compounds. Then second, solubility. Due to non-polar nature of these alkenes are insoluble in water but soluble in non-polar solvent like ethers, benzene or chloroform. Then third, boiling point. Boiling point of the alkenes increases with increase in the molar mass of alkenes. That is, the number of carbon atom increases in the compound of alkenes, then boiling point also increases. Branch chain alkenes have lower boiling point than that of corresponding straight chain alkenes. These are the physical properties of alkenes. Now we are going to see next point, chemical properties of alkenes. Now these alkenes are more reactive than that of corresponding alkanes. This is due to presence of pi bond or pi electrons in the alkenes. That is, these alkenes possesses carbon-carbon double bond, and due to presence of this pi bond or pi electrons, these are weakly bonded electrons or electron pair, and therefore these compounds or these alkenes easily undergo addition reaction. Now these alkenes undergo electrophilic addition reaction. That is, these alkenes undergo electrophilic addition reaction. Now here first reaction we are going to see is addition of dihydrogen. That is addition of H2 molecule. This reaction is also named as hydrogenation, or it is reduction reaction. Addition of hydrogen molecule is called as hydrogenation. Now here this is general reaction. When alkene undergo hydrogenation in presence of this dihydrogen and catalyst, metallic catalyst like platinum or palladium at room temperature, then addition of this H2 molecule takes place across this double bond of alkene to form corresponding saturated compound, that is alkane. This is alkane. Formation of alkane takes place. This is simple hydrogenation or reduction of alkenes. Now example, this is ethene or ethylene. When this ethylene is heated in presence of nickel catalyst, if we use nickel catalyst, then you have to carry out this reaction at higher temperature. Then here hydrogenation of this ethene is carried out. Addition of this H2 molecule takes place across the double bond of this alkene to form CH3. That is, this ethene is converted into ethane. This reaction we have seen in alkanes, in the preparation of alkanes from alkenes. This is repetition again. Second reaction we are going to see is addition of halogen. That is, addition of halogen molecule, that is Cl2Br2 or I2 molecule across the double bond of this alkene. This reaction is also named as halogenation reaction. Now when alkenes, this is alkene, when alkene is treated with halogen molecule, that is X2 molecule, in presence of non-polar solvent like carbon tetrachloride at room temperature, then this addition of this X2 molecule takes place across the double bond of this alkene to form vicinal dihalide. Addition of X2 takes place across the double bond of this alkene to form vicinal dihalide. Dihalide means there are two halogen atoms, and vicinal means these two halogen atoms are present on the adjacent carbon atom. Then it is called as vicinal dihalide. This is the general reaction. That is when alkene is treated with halogen molecule in presence of non-polar solvent like carbon tetrachloride at room temperature gives vicinal dihalides. Now for example, this is ethene. When this ethene is treated with chlorine molecule in presence of carbon tetrachloride at room temperature, then addition of this chlorine molecule takes place across the double bond of this alkene to form CH2, CH2, Cl, Cl. This is 1,2-dichloroethane. Formation of 1,2-dichloroethane takes place. Then we are going to see second example. Now this is propene. There are 3 carbon atoms, 1, 2, 3. This is propene, and when this propene is treated with bromine molecule in presence of carbon tetrachloride at room temperature, then addition of this Br2 molecule takes place across the double bond of this alkene or propene to form CH3, C, H, Br, CH, Br. And here hydrogen atom. That is here formation of 1,2-dibromopropane takes place. That is when propene is treated with bromine molecule in presence of carbon tetrachloride at room temperature, formation of 1,2-dibromopropane takes place. This reaction is very important reaction because here the color of this bromine is red-brown color. And when this bromine, red-brown colored bromine is added in the propene, then this color of this bromine becomes colorless. And therefore, this test is used to identify unsaturation in the compound. Therefore, this is important reaction. Now we are going to see third reaction or third chemical property of these alkenes is addition of hydrogen halides. Now hydrogen halide means hydrogen means hydrogen atom and halide means halogen atom, that is HX, or this HX may be HCl or HBr or HI. Now this reaction is also known as hydrohalogenation reaction. That is addition of hydrogen and halogen atom is called as hydrohalogenation reaction. Now we are going to see the general reaction. Now this is alkene, general alkene, C double bond C. When addition of this HX or hydrogen halide is carried out across the double bond of this alkene, then addition of this HX takes place like this to form alkyl halide. This is alkyl halide. Formation of alkyl halide takes place. This is general reaction, simple addition reaction. When alkenes are treated with hydrogen halide, then addition of this HX takes place across the double bond to form alkyl halide. This is saturated compound, that is unsaturated compound is converted into saturated alkyl halide. Now we are going to see addition of HCl, HBr or HI across the double bond of this ethene. Now this ethene is a symmetrical alkene. Symmetrical means when we draw a symmetry line on this double bond, then there are same number of carbon atom and same number of hydrogen atom on both sides of the double bond. This is ethene. When addition of this HBr is carried out across the double bond of this ethene, then addition of this HBr takes place across the double bond to form CH2Br, CH2H, that is CH3. That is, this is CH2Br, CH3. Formation of this compound takes place. This is ethyl bromide. That is, here when symmetrical alkene undergo addition reaction with HBr, then we'll get ethyl bromide as a product. Now we are going to see next reaction, addition of HBr across the double bond of unsymmetrical alkene. Now we have started third reaction, that is addition of hydrogen halide, or it is also named as hydrohalogenation reaction. And we have seen that when alkenes undergo addition of HX, then we will get corresponding alkyl halide. Then we have seen that when addition of this hydrogen halide is carried out across the double bond of symmetrical alkene, then formation of only one product takes place, that is alkyl halide. We have seen the example when ethene is treated with HBr, then formation of ethyl bromide takes place. Now we are going to see the second type, addition of HBr to the unsymmetrical alkene. That is, addition of this HBr is carried out across the double bond of unsymmetrical alkene. Now here, this is the example of unsymmetrical alkene, that is CH3, CH double bond, CH2. Now if we draw a symmetry line on the double bond, then here on the one side there are 2 carbon atom and 4 hydrogen atom, and on either side there is only 1 carbon atom and 2 hydrogen atom. Therefore it is example of unsymmetrical alkene. Name of this compound is propene.
There are 3 carbon atoms.
And therefore it is propene. Now when addition of this HBr is carried out, then here there are formation of 2 products takes place. That is, here if this hydrogen atom goes to this carbon atom and this Br get attached to this carbon atom, then we'll get here CH3, CH, Br, CH3. And if this addition of HBr is carried out like this hydrogen atom get attached to this carbon atom and this Br get attached to this carbon atom, then we'll get second product CH3, CH2, CH2Br. That is, addition takes place across this double bond by 2 ways, and here we'll get mixture of these 2 products. Now name of this product is 2-bromopropane, and this is 1-bromopropane. 1, 2, 3 carbon atom, therefore parent alkene is propane, and at one position there is bromine, therefore it is 1-bromopropane. But experimentally it is found that this 2-bromopropane obtained as a major product, that is 85% product is 2-bromopropane, and this 1-bromopropane is obtained only as a 15%, that is minor product is obtained. This is major and this is minor product. That is 2-bromopropane obtained as a major product, 85% 2-bromopropane obtained, and only 15% 1-bromopropane obtained. Now these are the experimental values, and therefore here Marconi-Kropf rule is used. What is the Marconi-Kropf rule? When addition of unsymmetrical reagent. Now which is the unsymmetrical reagent? HX, that is hydrogen halide. Here it is HBr. When addition of unsymmetrical reagent, that is HX, is carried out across the double bond of unsymmetrical alkene, then negative part of the reagent, that is X minus, gets attached to that carbon atom of alkene which carries less number of hydrogen atoms. Now look here, according to Marconi-Kropf's rule, negative part of the reagent. Now here in HBr, Br is negative and hydrogen is positively charged. Then negative part of the reagent, that is Br minus, get attached to that carbon atom which have less number of hydrogen atom. Now this carbon atom carries less number of hydrogen atom. This carbon atom carries more number of hydrogen atom. That is, in this case there are 2 hydrogen atom. Here there is only 1 hydrogen atom. Therefore negative part of the reagent gets attached to that carbon atom which carries less number of hydrogen atom and will get 2 bromopropane as a major product, or 85% 2 bromopropane is obtained. This product is obtained according to Marconi-Kropf's rule. What is the Marconi-Kropf's rule? When addition of unsymmetrical reagent, that is HX, is carried out across the double bond of unsymmetrical alkene, then negative part of the reagent goes to that carbon atom of alkene which have less number of hydrogen atoms, and therefore 2 bromopropane is obtained as a major product in case of this propene when react with HBr. We have seen that according to Marconi-Kropf's rule, when addition of unsymmetrical reagent is carried out across the double bond of unsymmetrical alkene, the negative part of the reagent, that is X minus, gets attached to that carbon atom of alkene which have less number of hydrogen atom. Now we are going to see next point, that is anti-Marconi-Kropf's rule, that is addition of HBr to the unsymmetrical alkene according to anti-Marconi-Kropf's rule, or anti-Marconi-Kropf's addition or peroxide effect, or it is also named as Kharash-Mayo effect. Now when addition of this HBr is carried out across the double bond of unsymmetrical alkene, this is propene. When addition of this HBr is carried out across the double bond of this alkene in presence of any peroxide, either it is hydrogen peroxide or it is benzoyl peroxide, that is C6H5CO 2 times O2. This is benzoyl peroxide. Now when addition of this HBr is carried out across the double bond of this unsymmetrical alkene, then negative part, that is Br minus, get attached to that carbon atom of alkene which have more number of hydrogen atom. That is, here this CH2 group possesses 2 hydrogen atom and this CH possesses only 1 hydrogen atom, and therefore this Br get attached to that carbon atom which have more number of hydrogen atom in presence of peroxide, and then this hydrogen get attached to this carbon atom and we'll get here CH3, CH2, CH2, Br. That is 1 bromopropane as a major product. That is, this reaction if carried out, that is addition of HBr across the unsymmetrical alkene is carried out in presence of peroxide, then addition takes place according to anti-Marconi-Kropf's rule. That is, negative part of the reagent goes to that carbon atom of alkene which have more number of hydrogen atom to form 1 bromopropane as a major product. Now this effect is carried out due to presence of this peroxide, therefore it is called as peroxide effect. This scientist, that is Kharash and Mayo, these 2 scientists studied this reaction and therefore it is also named as Kharash-Mayo effect, and this reaction is carried out according to anti-Marconi-Kropf's rule. therefore it is also named as anti-Markovnikov addition. Now here the statement of anti-Markovnikov rule or Halogenation effect is when addition of unsymmetrical alkene, that is HBr, is carried out across the double bond of unsymmetrical alkene, then negative part, that is Br minus, gets attached to that carbon atom of unsymmetrical alkene which carries more number of hydrogen atom. Now we are going to see second example. Now name of this compound is now 1, 2, 3. Parent alkene is propane, there is double bond, therefore it is propene. At 2 position there is methyl group, therefore it is 2-methyl propene. And when this addition of this HBr is carried out across the double bond of this alkene in presence of benzoyl peroxide, or it is C6H5CO 2 times O2, that is benzoyl peroxide, then negative part goes to that carbon atom of alkene which have more number of hydrogen atom. Therefore this Br get attached to this carbon atom and this hydrogen get attached to this carbon atom to form CH3, CH2, CH2Br. Here formation of this alkyl halide takes place. Name of this alkyl halide is 1, 2, 3. At 1 position there is bromo, therefore it is 1-bromo, 2-methyl propane. It is 1-bromo, 2-methyl propane. In this way, when the addition of unsymmetrical reagent is carried out across the double bond of unsymmetrical alkene in presence of peroxide, then addition takes place according to anti-Markovnikov rule, that is negative part of the reagent, that is Br minus, get attached to that carbon atom of alkene which carries more number of hydrogen atom. It is called as Halogenation effect or peroxide effect. Next reaction, that is reaction number 4 of alkene, is addition of sulfuric acid. Now formula of sulfuric acid is H2SO4. Now this H2SO4 can be written as HOSO3H. Now here when alkene, now this is general reaction, when alkene is treated with cold and concentrated sulfuric acid, that is H2SO4, this H2SO4 is written as HOSO3H. Then here this hydrogen is positively charged and this OSO3H is negatively charged. Now here addition of this HOSO3H takes place across the double bond of alkene, and here this hydrogen goes to this carbon atom and this OSO3H goes to another carbon atom. That is addition of this HOSO3H takes place across the double bond of this alkene. Now in case of unsymmetrical alkene, this addition takes place according to Markovnikov's rule. Now here we will get here OSO3H and H. This is alkyl hydrogen sulfate. That is when alkenes are treated with cold and concentrated H2SO4, then simple addition reaction takes place to form alkyl hydrogen sulfate. Now we are going to see example. Now this is ethene molecule, CH2 double bond CH2. When addition of this cold and concentrated H2SO4 is carried out across this double bond of alkene, then here negative addition of this HOSO3H takes place across the double bond of this ethene molecule to form only one product, that is CH3 CH2 OSO3H. This is ethyl hydrogen sulfate. That is, when ethene is treated with cold concentrated H2SO4, then addition of this HOSO3H takes place across the double bond of ethene. Now here this ethene is a symmetrical alkene and therefore we will get only one product. But when this addition of HOSO3H, that is cold and concentrated sulfuric acid, is carried out across the double bond of this unsymmetrical alkene. Now this is unsymmetrical alkene, propene. Now here there is double bond. If we draw a symmetry line on this double bond, now on the one side of double bond there are 2 carbon atom and 4 hydrogen atom, and on other side there is only 1 carbon atom and 2 hydrogen atom. Therefore it is unsymmetrical alkene, and when addition of this H2SO4 is carried out across the double bond of this unsymmetrical alkene, then negative part of the reagent goes to that carbon atom of alkene which carries less number of hydrogen atom to form CH3, C, H, OSO3H, CH3. This is isopropyl hydrogen sulfate. And this addition takes place according to Marconi-Kropf rule. This addition takes place according to Marconi-Kropf rule. That is, ethene is converted into ethyl hydrogen sulfate and this propene is converted into isopropyl hydrogen sulfate by the addition of this HOSO3H. Now this alkyl hydrogen sulfate or this ethyl hydrogen sulfate or isopropyl hydrogen sulfate, when it is hydrolyzed or when it is water molecule is added in this alkyl hydrogen sulfate and it is heated, then here formation of alcohol takes place and this H2SO4 is regenerated. Now look here, this is, that is, it is hydrolysis of alkyl hydrogen sulfate. Now this is ethyl hydrogen sulfate. That is, it is obtained here. That is, when ethene is treated with cold and concentrated H2SO4 gives ethyl hydrogen sulfate. This ethyl hydrogen sulfate, when addition of H2O is carried out in this ethyl hydrogen sulfate, then here formation of alcohol takes place. That is, CH3CH2OH is formed. Now here this addition of H2O takes place like this. HOH, removal of this H2SO4 takes place and here OH group is formed. This is alcohol, ethyl alcohol or ethanol plus H2SO4 is regenerated. Formation of H2SO4 takes place. Now this is isopropyl hydrogen sulfate. This isopropyl hydrogen sulfate is obtained when propene is treated with cold and concentrated H2SO4, then formation of isopropyl hydrogen sulfate takes place. Now this isopropyl hydrogen sulfate, when it is treated with water molecule, when hydrolysis is carried out, then here we will get here this OSO3H group is converted into OH group and we will get H2SO4. That is, here we will get CH3, CHOH, CH3, that is propane 2OL, or it is isopropyl alcohol plus H2SO4. That is, when this alkyl hydrogen sulfate undergo hydrolysis or addition of water molecule and heated, then here this reaction mixture is heated. Then here formation of alcohol takes place. Now we are going to see the next example, this one. This is 1, 2, 3, it is propene. At 2 position there is methyl group, therefore it is 2-methyl propene. Now this 2-methyl propene is reactive alkene, and when this 2-methyl propene or reactive alkene is treated with water molecule in presence of cold and concentrated H2SO4, cold and concentrated H2SO4, then direct addition of this H2O or HOH, here H is positively charged and OH is negatively charged, addition of this water molecule takes place across the double bond of this alkene. This addition takes place according to Marconi-Krop's rule, and according to Marconi-Krop's rule, negative part goes to that carbon atom of alkene which have less number of hydrogen atom, and this H plus goes to this carbon atom to form CH3, C, CH3, OH, CH3. This is 2-methyl propane 2OL. That is 2-methyl propane 2OL, or it is tertiary butyl alcohol. Formation of tertiary butyl alcohol takes place. In this way, when alkenes undergo addition reaction with sulfuric acid, then formation of alkyl hydrogen sulfate takes place, and this alkyl hydrogen sulfate when heated with water gives corresponding alcohol.